So today we will going to be solving yet another AI assisted coding problem. Let's go. So someone built a word analysis system but left some bugs in unfinished work. The word list class manages a collection of words and can check substring relationships. The solver class should find all words that contain other words from the list as substrings. As usual, we need to find the bugs, implement the solver, and optimize. So I will navigate the code base first and I will run main. Okay, input words, all of those, valid words, of those container words, none. I guess I will figure out what container words are. To find all words that contain at least one other word as a substring. Okay, I see. So here our expectation is that, for example, apple contains app, and banana contains nana, and application also contains app, and application also contains cat, but it's fine that it can contain just one of those words, and then it will be considered a container. So essentially it's a problem where like the brute force solution would be we iterate over all words, all of n words, and then we are starting at all the possible letters, and then we're comparing starting at this letter whether like the next part of the word is similar to whatever other words we have, and that would be n words times m squared, where m is the number of letters in the word. So nm squared operation, which is long, we can also optimize that. I already understand that we will be using try here as a data structure, but let's do things step by step. So this is the main. Let's now see the words. So load words, we are loading those from data, and we have words small. Okay, so essentially this list. Words medium, large, huge. Huge, let's see, huge. Okay, like some 10,000 lines or something. And medium, just 500. Fine. Okay, so now let's see. We have solver, find containers, return a list of words that contain other words from the list. A word cannot contain itself. Fine. Test solver, test word list. Okay, so I think first instructions. Complete find containers in the solver. Test large in solver test. So these we're solving as the next tests. These we're solving as the first test, I think. Fix the bug. Okay, for word list. Fine. So let me just uncomment those. And now I will check that those tests are actually failing. Not all of the tests are failing. For example, test contains longer word. Okay, I will need to see word list first. So self words and self word set. For worded words, self is valid word, and word not in self word set, self words append word, self word set add word. Okay, so we have both the set and the word. Is valid word. Okay, we don't want non-empty, no spaces. Or word is equal to an empty word. Because we don't want empty words. Maybe that's one of the bugs. Get words. So we have get words copy. So we are copying the list. Get word set contains as substring. Okay, this is definitely not what it should be. Let's def contains a substring container which is a string, okay, self container which is a string, and then contained which is also a string, and then we return boolean. And for this function implement this function. Let's use, okay, close on it for implement this function. This is the first step. How do you implement this function? Remember to start with all valid with all valid starting indices, and the contained should always be shorter. Okay, and here while it's implementing, I want to create this in this way, and then try will be equal to a different class that I will call none by default. So if try is none, return this and else pass for now, but we will be implementing another function here. Okay, let's see, contains as a substring. If length contained bigger or equal, then return false. Check all valid substring indices. So for I in range len container minus len contain plus 1. So I will need to check that specifically, but the text on the right is small, so let me just paste it here. Okay, so let's say we are checking word A, B, C, D, and we are checking whether B, C, D is in it. So we need to start at 0 and 1. So given that we need to start at those two indices, so let me be careful here. Okay, since we need to start with all those indices, let's say length of container is 4 minus length of container is 3 plus 1 equals 2, and this is correct. This is exactly what we need. We need range from 0 to 2. Okay, and then also the words cannot be empty, so they're at least length of 1. So in this corner case, yeah, it will be just iterating over 0, so we will not even get inside this list. Okay, so now if container starting at 1 at I or to I plus length to 3, yeah, return true. Okay, so this should work fine. Let me now test the word list and see how it works. And okay, we now have more failures, which is fine, which is funny, but we will just iterate over those. Okay, so word list of apple, banana, and cherry. Set equal word count is equal to 3. This is fine, so I don't think this fails, right? So now test remove duplicates. Test word count 2, that's correct. Contains basic, so self-assert tree contains basic. Do we have it here? No. Contains the different positions. Hello HE, hello low, hello ELL, and we still are passing this correctly. Okay, now test contains the same word. Expected false. It shouldn't contain the same word. Test contains longer word. Always false. It can never contain longer word. Test valid word normal. Oh, is valid word. I think it checks words. Word list, sorry. So is valid word. Yeah, it should be returning true, right? Non-empty, no spaces. Yes. So I think test word list. So is valid word should be true. Test valid word empty, so this should be false. And this was the bug that we actually caught and fixed. Test valid word spaces. So hello world is not valid, so we are removing this. Now test filters invalid words. So this is invalid word and this is invalid word, so the expected count is 3. Now let's rerun the tests. Nice, we have passed all the tests. Let's move on. So we now need to implement solver. Let's again create 2 solutions. Def find containers simple self, and it returns also the same thing, list of strings. So here we don't have a try yet, and then what we do is for word in self word list for another word in self word list if word self, oh yeah, it's not word list, it's like word list get words or something, right? Word list get words. They're also doing this copying-ish attempt. Actually, don't plan to mutate this, so I want to remove this copying all the time for now. At least let me check that this still passes all the tests. Yes, it does. So I don't want this unnecessary copying because I don't want to modify this in place. And then if self word list here get words and here get words. So when we are creating the word list, let me remind myself. So yeah, so we are checking whether the word is valid and we are removing duplicates already. Okay, so this is fine. This is running as expected. So if self word list, what I'm trying to check, yeah, there is another contains a substring. contains a substring, word, another word. I'm thinking when I'm using try how I would be approaching this, but that's fine. So yeah, I will need to change the method there. Oh no, I won't need to change. I will need to track how many letters do I have when iterating over try. Okay, so if self contains another word, then we also will have answer here is a list, and then answer and word, and continue. Break. So we don't, if we have found one word, we don't need to iterate over all the other words. So return answer, and let's see now test solver. One test is passing, but it's not asserting anything. So oh yeah, I haven't passed this to this function here. So return if length of self words word list get words is smaller than 100, return self find container simple. Okay, we have actually passed this test. Now let's see test simple containers. Okay, so what we are checking? Sorted result, sorted expected. So expected will be equal to apple and banana. Okay, we have passed two tests. Let's check this. So here, no words contain another. So we will just pass this. Okay, test multiple containers. Yeah, that's where we are breaking. We don't, this worker in rework, they can contain the same work, working, homework. So basically 4. Expected count is 4. Okay. Test nested containers. Oh, that's interesting. And container can also be contained by an, oh yeah, that's fine. So A cannot contain itself. 1, 2, 3, 4. So it will still be 4, even though those other words are containing each other. All of them are containing A. So by default, everything doesn't matter. Else doesn't matter. Okay. So test from file small. Oh yeah, we should find some containers in the curated list. Yeah. So let's see world small, right? I see 2, 3 words, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So I think it should be at least 13 if I'm not missing something. So expected mean is 13. Okay, maybe I have missed something. Let me just check myself once So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11. Okay, not 13, definitely. So let's just have test solver as 12. Given that we can find 12, I think that's fine. So now we are solver file and containers. Expected time, I don't know, 1 second. And this will fail because currently for 500 words, oh, sorry. For 500 words, we don't have any implemented functionality. So now let's do this. So I will be importing from collections, import default ticked, and I will be implementing a class of try and def init self, and the try will have self next will be default ticked of try, self end will be false by default. So this is our class of try, and now let's start by changing our solver to word list. So let's now define substring self container try, which is try, and theoretically we need to implement it in another class so that we can input it here. Let's just ignore this for now. So we will be still outputting the same Boolean value. So let's ask AI assistant, given, so let's just quickly call this function here, return self this, and we are passing container, but then we are also passing the try. Contained also by default will be none. Yeah, so here we are checking against the try, and substring with try, that the given the try class, implement this method in word list. So what it needs to do, it needs to check everything against the try. Let's see what it has written for us. I will copy it first and then figure out if it's correct or not. Okay, so checks if container contains any word from the try as a substring, uses the try to efficiently check all possible substrings. Try to merge. We also need to okay. No, it's not. It hasn't implemented things correctly. Let's start with a different thing then. Let's clear this so that it doesn't get confused. And for solver, self try equals try. Then let's implement another method. So plus here def populate try self run implement function get all the words into the try structure from try structure given this implementation of try. Okay, this looks correct. So I should add test. To check correctness of the implementation. Let's see if it has implemented a good test or not. So we already are implementing both of those things, I think, right? Yes. Now words, word list, solver populate try. Let's actually ensure that we are running this populate try by default. Here on instantiation. Self populate try. Okay, so test solver, then we can remove that. So current for char and cat self assert in char current next, current equals current next, self true. Okay, check car. Yes. Yes, and assert for current end. This is good. Check non-existent. Okay, let's see if this test error try object has no. Okay, where? Oh, I put this in incorrect place. Okay. So at least does this test work? Test populate try. So we are always returning none, right? Right now. This is strange. Let's see what's going on. So if else return self find containers. Oh, find containers. Try. I think we were just overwriting this method with a new one. Okay. Test medium word list. Okay, we are just returning none for now. Fine, but try works, so that's good. Let's now, given all that, go back to AI Assistant and for word list. Here, write this method. Remember that any word in try should be shorter, strictly shorter than container word. So that's one of the things that we want to ensure that we check. Okay. So Find has implemented it as two methods. Works for me. Let's see how it implemented this. So for start position and range length of container self, search from position, container start position, try. Okay. If then we return true, otherwise return false. Okay, this seems good to me. Now let's see, search from position. Current node equals next. If found a complete word and it's shorter than container, we are only doing this so that the word doesn't match itself in the try. So if we iterate over the whole length of container, we can just remove that and we can do length of container -1. So that would require any I that we are considering. Oh no, cannot do that because sometimes we'll start not at the first element. Okay, so then let's see if this is fine. So I minus start position plus 1. I will be some position, then the starting position will be the position, so it can be the length of, no, I can be at most length of container -1. So then minus starting position can be 0, length of container -1 plus 1. So if, as long as, yes, it's smaller, strictly smaller, than we return true. Okay, so this code looks good. Fine. So let's again test solver. Okay. Why? Because we have still not implemented this. So now what we need to do, we just need to do answer and forward if try equal self try. Answer append word and continue, not break in this case, continue, return answer. Okay, the object of try has no length. Length word list line 45. Word list line 45. Okay, I see. If oh, I see. I haven't changed this. Okay, we actually have passed this this test. So let's also do a few things. So test solver. For solver, let's create this threshold. So threshold equals 100. Let's make it 10. Okay, all tests are run. So basically, I'm assuming that now 0. We are always running things through the try now. Now let's get it back to 100. I was just checking that solver works and all of those things are still working correctly. All of this functionality. Now let me just try checking. Okay, so expected time 1, fine. Then the SS test properly try 5000. Expected time, we don't know what's the expected time. Let's say 2 seconds. And 10,000 words. Oops. Let's also say 2 seconds. Yep. Maybe even make it was faster than 1 second. Am I running the correct tests? Let's just, to be sure that I'm not mixing anything up, I have this. Yep, printed out. Okay, finally I'm in a good spot. I have implemented the whole code. I have used AI in the right manner. I have finished the whole thing in 40 minutes. Let's just hope that the actual problem that I get on the interview will be as easy as this one, or maybe it wasn't easy, but here you basically just need to know the right data structure. Thanks everyone who was watching.